Lesson 11.7, the Binomial Theorem. We're going to actually focus on expanding using the Binomial Theorem and not really get into the actual formula. What we're going to do is we're going to utilize Pascal's triangle. And Pascal's triangle is created by having the outsides of the triangle be 1s, and then the inner numbers are created by the sum of the two numbers above each new number. And the properties of this is that the rows have coefficients that are found in expanding binomials to any power. So for example, here we have p plus q to the 5th power. And to the 5th power we mean that we're going to use row 5. And row 5 represents the second number in. So row 4, 3, 2, 1, etc. And this row has the numbers that we will use in our expanding of the binomial p plus q. Now remember, p plus q to the 5th means p plus q times p plus q times p plus q, so 5 times. And that can be a very lengthy handwritten expansion. But with the binomial theorem and Pascal's triangle, we know that the first numbers of each term that we would have through expanding this to the 5th power would be the row numbers, and then p and q would be written next to each one. And then you have the powers, and it goes, the first term, p, starts with the highest power, which is the row number, 5, and it decreases by 1. And the q goes the opposite direction, starts at 0, and increases by 1. And they are all added. And remembering, of course, that anything to the 0 power is 1, we can take those out. This would be our solution. Very quick and efficient when you use Pascal's triangle. If this were minus, then you would start with a plus. Your first term is positive, but then you would alternate every other term as a different sign. And we'll talk about that in a moment too. Here's t minus s to the 8th. Okay, so we have the 8th row, because it's a power of 8. We have all those numbers. So 1, 8, 28, 56, 70, 56, 28, 8, and 1. Everything's there, good. Then we go to the letters, TS, TS, and so on. And we have our powers. So 8, the first variable is t, so that one starts at the highest power and decreases. 8, 6, 8, 7, 6, 5, 4, 3, 2, 1, 0. And the other one starts at 0 and increases. And again, we would take out the ones to the 0 power. And since it's a negative, the first term is a positive term, then we alternate after that. and that is expanded. Now notice that our answer has all the same numbers that were in the row when we started. That's because there are no numbers in the parentheses. Again, this one, factorial, is a quick basic review of what does factorial mean. It means 6 times 4 times 5 times 4 times 3 times 2 times 1. Then 2 times 1, and then 4 times 3 times 2 times 1. So factorial means starting with the number, multiplying the number below it all the way down to 1, not including 0. Then we can cross out because they're all being multiplied. 2 goes into 2 once, 2 goes into 6 3 times, and you end up with 3 times 5, which is 15. Now here's a question where we have 3 in there, number 3. Now the same process is going to be done. Power of 4, so row 4. We have 1, 4, 6, 4, 1. Now I'm going to put 3x in parentheses and then y. The reason I put the 3x in parentheses is because we have to remember that when I write a power above it, everything on the inside must be taken to that power. I'm basically doing the same thing I did before. But now I have to remember, I have to take 4 to the third power and x, or excuse me, 3 to the fourth power and x to the fourth power. And when I do that, 3 to the fourth power is 81, x to the fourth power, and the y is gone. Now it's a minus sign, so this is where we alternate. Again, the first term is a positive number, so that stays positive. Then I have to take 3 to the third power. Alright, that will give us 27. Then I have to take it times 4. That should give us 108. X to the third power, y. Now again, 3 to the third power is 27. Then I have to take it times 4. That's how I get the 108. Now I have to take 3 and square it, which gives you 9. 9 times 6 gives us 54. Again, x gets squared. 3 to the 1 is 3. 3 times 4 is 12. And that is our expanded form. So when we have a number inside the parentheses, that's going to affect our row coefficients. So instead of having an answer with the actual row of Pascal's triangle in there, my numbers have changed. Now, in final closing here, final comments, this is considered the first term, the second term, third term, fourth term, and fifth term. So you could basically be asked the question, what's the third term of this expression? And if you expand it, like you did, this would be considered the third term. Now there's a formula for this, but we don't get into it here, that would give you just that term. But right now we're going to do it longhand and work our way up to that term. This ends lesson 11.7.